Hi everyone, and welcome to today's video. In this video I'm going to be talking about the basics of condensation reactions. Now, condensation reactions are a new type of reaction for level 3 and they are absolutely key. I can guarantee without question of a doubt that there will be a question, probably several, on condensation reactions in your exam this year. So without further ado, let's have a look at the definition of a condensation reaction first off. Okay, so a condensation reaction is a reaction that happens when two molecules join together to make a larger molecule, and a small molecule such as H2O or HCl is also formed, so it's a byproduct. The name condensation reaction obviously comes from the formation of water, but it doesn't have to be water that's formed, though it's usually water, HCl, or those are probably the two main ones. Okay, so we use condensation reactions to make a variety of different types of compounds. So particularly amides and esters, polyamides and polyesters, and also sort of acyl chlorides form a condensation reaction as well. So let's have a look at some of these examples. The first one is the formation of an amide. Now, I will show you some structures of these in a second, but basically, if you take an acyl chloride and some concentrated ammonia, or a primary amine or a secondary amine, then you can react them together to form an amide, primary, secondary, or tertiary, depending on what you've used, and you form HCl as a byproduct. That makes it a condensation reaction. So let's have a look at a few of these. So let's picture this reaction. Okay, we have our acyl chloride here and ammonia. So this is going to make a primary amide. And the way it works is that the Cl and one hydrogen of the ammonia come together and they make our HCl, and the rest of the molecule comes together to form our amide, okay, plus HCl. So we've got that general structure. Now it doesn't matter whether we have a primary amide, ammonia to make a primary amide, a primary amine to make a secondary amide, or a secondary amine to form a tertiary amide. Let me show you. Okay, so here we've got our acyl chloride and our primary amine, and again what we're going to do is take away the Cl and the H and join the rest of it together. So here you can see we've taken away the H and the Cl. That gives us our our small molecule byproduct, and down the bottom is our primary amide, our secondary amide, because there are two different carbon chains attached to the nitrogen. That makes it a secondary amide. And the same kind of process happens with a formation of a tertiary amide as well. The second very important type of condensation reaction is the formation of an ester. Now, esters can be formed from both carboxylic acids and from acyl chlorides, both in condensation reactions, and I'll talk about these more when I talk about esters as well. But what happens is we have an alcohol. It's actually very similar to the formation of an amide, to be honest, because you take the same kind of ideas and you join them, two molecules join together, take away water, and away you go. Now, if you use a carboxylic acid and an alcohol, then this reaction is very slow. And so you need to heat it to make it go faster, and you need sulfuric acid. Now, sulfuric acid does two things. The first thing it does is it acts as a catalyst in the reaction, so it speeds it up. The second thing it does is it's a dehydrating reagent. This is an equilibrium reaction, so it pushes the reaction towards the product side, increasing the yield. Water is formed as a byproduct in this, so let me just quickly show you the basics of this reaction. Okay, so this is the basics of an ester reaction. We have a carboxylic acid and an alcohol. Now I'm just drawing this in this way so that I can actually fit it all on this tiny weeny little board. It is an equilibrium reaction, so when you write this equation you do need to include the equilibrium arrow, and you do need to note the presence of concentrated sulfuric acid as a catalyst. So what happens? Well, what happens is that the first thing that happens is the OH from the carboxylic acid and the H from the alcohol come away and form water, and that then gives us the place, so a new bond forms between the oxygen on the alcohol and the carbon on the carbonyl group of the carboxylic acid, and they join together. And we have our ester formed, and you can see there I've put the two different colours in so you can see which parts of the molecules they have come off. Okay, so esters can also be formed from acyl chlorides and alcohols again, and very much the same reaction mechanism, but it's a much faster reaction. You don't need the sulfuric acid, the catalyst, you don't need to heat it, you just basically bung it in together, it reacts. The downside is that it does produce large amounts of gaseous hydrochloric acid, so it is quite a dangerous reaction. Industrially, this process is used much more to produce esters than the acid, carboxylic acid, and alcohol. But because of that gaseous HCl production, in smaller laboratories, we tend to use the carboxylic acids just for safety's sake. Okay, I'll just show you again the reaction for this one so you can see how it differs from the carboxylic acid. Okay, so here you can see the reaction with an acyl chloride. Again, the reactants are on the left-hand side, the acyl chloride at the top and the alcohol at the bottom. And what you see, again, the chlorine from the acyl chloride, the hydrogen from the alcohol, they come together to make HCl, and a bond forms between the oxygen of the alcohol and the carbonyl group of the acyl chloride to make an ester. Now this is exactly the same ester as I've made in the previous reaction. Three differences. The first one, you'll see that the arrow here is a single arrow, it is not an equilibrium arrow. Second thing, there's no concentrated sulfuric acid. And the third thing is that the water is now HCl. So those are the main differences between the reaction with acyl chlorides and carboxylic acids to make esters. Okay, so to recap the idea of condensation reactions, we have two molecules that join together to make a larger molecule with the formation of a small molecule such as water or HCl as a byproduct. Please learn that definition. It comes up in exams probably every other year, and being able to recognize a condensation reaction on site, again, is something that comes up. We'll talk about the use of condensation reactions to form polymers in a later video, but right now, that's the key ideas around condensation reactions. I'll see you next time.